I'm Jonathan Stark, and welcome to Inside the Brackets. Today we're talking about performance in cross-platform apps and what's happening at the leading edge of HTML5. Joining us today are Dave Herman, Principal Researcher and Founder of Mozilla Research, Tatiana Shpeisman, Principal Engineer at Intel Labs, Dave Fetterman, Vice President of Engineering at Famous. Let's begin by clarifying what we're talking about when we're talking about performance in HTML apps.
Well, in the web platform, there's so many different parts that go into the execution of a web application. And from the user's perspective, it's really about how fast can their app be displaying what they want to see, and how responsive is it when they're trying to interact with it. But from the developer's perspective, there's a lot of different parts that go into that, and that can start from network performance. So, are they making sure that they're optimizing the delivery of the assets that have to go into building the app? That can be on the JavaScript side of things, so the logic that goes into their application and how optimized the JavaScript engine they're working on is. And then there's a lot of steps in between. There's the layout of the components on the page. There's the rendering of the graphics to the screen. So it's a pretty rich space. There's a lot of different parts that go into optimizing an application.
Great. What other Dave? What do you feel like are some of the bottlenecks right now?
For people choosing to develop a native application over an HTML5 or JavaScript-based application, there's a few categories that are pretty common. One that's been largely solved by technologies like PhoneGap is access to some of these native services that are part of the device, camera, address book, and so forth. On a deeper level, at the hardware, at the sort of hardware or infrastructure level, things like multi-threading, things like being able to execute a lot of stuff in parallel, access the native threads of the system, that is a big gap. But I think from the user side, one of the big chasms is the kind of UI interactions they should be able to expect to have.
So Tatiana, what are you working on that would sort of address some of maybe the parallelism of what the browser can do today?
I'm working on parallel JavaScript. We would like HTML applications to be able to work as well as native application and as fast as native application. And to do this, they need to be able to take advantage of all available hardware resources. So if you look at the modern computers, mobile phones, this is hardware with multiple cores. So there are multiple cores there are vector instructions, there are graphic processors, all of which can deliver a lot of the performance, but JavaScript today has no way of accessing these resources. So we are extending the language in a very gentle way to allow JavaScript applications to have the same performance capabilities as native applications.
When you say gentle way, I like that. What do you mean by that?
We are trying to let JavaScript stay JavaScript, because there are many ways you can get to hardware, and often it is tempting to say, if we want to reach the performance of native code, let's just introduce native code into HTML. We are not doing this. We are preserving JavaScript. We are just extending JavaScript in a way it's natural to web developers to allow people to have access to hardware.
Can I add to that?
Yeah, please do.
So this has been a project that my group has partnered with Tatiana's group on. And one of the things that we wanted to aim for is that parallelism is often seen as a sort of super advanced topic and a very difficult thing to do. And what we wanted to do was introduce a few patterns where you can actually make very small changes to your code and suddenly be able to tap the parallel resources on whatever device that you're on. So things like, people are very familiar with some of the array methods in JavaScript, like array.map and array.reduce. We want to have parallel versions of those, so it actually feels very familiar and it still feels like a very high-level kind of programming. So it gives you that gentle on-ramp. It also may make it easier for you to refactor your code. So maybe you implement it sequentially and you find that there's a performance bottleneck, and you can just turn this array map into array parallel map, and without making any more changes to your code, suddenly see this part of your algorithm being able to tap those resources.
So what sort of operations would really benefit from this kind of parallelism? I'm imagining it's not laying out the DOM, it's more like crunching numbers or something like that, or is that not right?
I think crunching numbers, what we focused on for now is data parallelism, where you have a large amount of data and you want to do the same thing to all of that data. So map is a good good candidate for that, because map is all about, I have some number of elements of data in my collection, and I'd like to do a similar thing across all of them.
I'd like to chime in on this a little bit. When we say data parallelism and performance, people think that what we are going to be crunching is numbers, but usually it's not numbers, it's something much more real, like, for example, pixels. If you think of an image, it consists of a lot of tiny pixels, and all those pixels can be crunched together in parallel, and what you see is pretty cool video effects, or recognizing faces, or recognizing objects, and all of this running in the browser. And to make that possible, we need to be able to crunch those pixels in parallel.
Sure. So even things like making a video translucent or something, it needs to recalculate all of those pixels in real time across the entire video, and this sort of thing would make that more performant.
Yeah, that would be a perfect example.
Great. So at Famous, you guys have taken a much different approach. You've attacked performance at a much different level in a much different way. Can you talk about that a little bit?
Sure. So at Famous, the approach these guys took was basically trying to use the right tool for the right job. They'd been trying to develop one of these full-featured applications with sophisticated, beautiful UI using web technology. And they found that, hey, the best way to go about this was to completely start over and to basically build a rendering engine in JavaScript itself. And it seemed like a crazy idea. The first time I heard it, I thought it was ridiculous. But then they showed me what they built, and I'm kind of a believer now. The basic idea is that the web browsers, although they have very talented engineers who've been working on them for a very long time, have been basically optimized to render text documents, right? To render fixed layout documents or layout that changes in predictable ways. But what the guys at Famous are doing is they're saying, look, if you want to build applications, then let's use the right tool for the right job. So let's sort of end around a lot of the stuff in the browser that is really good at doing text layout, and instead have a JavaScript core that Famous provides that allows users to actually write the kind of components and visualizations that talk directly to the GPU through through the WebKit style WebKit style property using affine matrices. So long and short, basically, like, we're basically doing a lot of the matrix calculation on the CPU in Famous in our platform and handing it right to the GPU to get the job done. And it turns out that it can be really, really fast.
Yeah, the demos are shocking. They're so smooth. So it is pretty impressive, so people should check that out for sure. All right, so Dave Herman, let's talk a little bit about Emscripten. I'm saying that wrong. Emscripten.
Yeah, it's a very awkward name. The goal of Emscripten, actually when it was started, it was a colleague of mine, a brilliant engineer named Alon Zakai. I asked him, why did you create Emscripten? And he said, well, I had this idea that you ought to be able to compile C++ to JavaScript so that you could take a native application and run it on the web. So that's the basic idea. It uses LLVM to do a lot of the heavy lifting. Basically, you take your C++, you compile it through LLVM, like other compilers like Clang do, and then the output of that runs through the Emscripten compiler, and what comes out on the other side is JavaScript. Now, as it turns out, the style of JavaScript that it generates is a very strange and particular style, this little arcane kind of dialect of JavaScript that happened to be one that was very recognizable to JavaScript engines, and they could start to build in special optimizations to recognize those patterns. So after Emscripten had been around for a little while, we were seeing that JavaScript engines were starting to optimize for that style of code. And over time, we were seeing the gap between running C++ code in its native environment versus running it through Emscripten on the web, closing down to, first we got sort of within that order of magnitude 10x on many of our benchmarks. After a while, some of the benchmarks were getting down to 5x. And over time, we decided that if we could really make that dialect precise, if we could formalize it and give it a specification, that we could actually narrow the gap down to under 2x. So that became ASM.js, or ASM.js, which we wrote a spec for and have been building more and more optimizations for. At this point, we're seeing, for our benchmarks, we're typically within 1.5x of a slowdown from native performance. So we're really closing that gap to native performance.
So what is a typical application that you would see someone want to do this to? I think the Unreal Engine was ported this way, so you could create like a 3D first-person shooter.
Yeah, so games is really the first market that we've been working with, and it's kind of the most straightforward one because it's the one that needs very little in the way of web APIs. Kind of similar to how Famous sort of circumvents some parts of the platform that it doesn't need to be able to get really that focus on the application side and avoid the text side. Mm-hmm. Similarly, games don't really care about your ability to float an image next to a panel of text. What it cares about is that you have a big canvas and you can render pixels to the screen very quickly. Over time, we'd really like to grow that set and look at new kinds of applications where being able to port very high performance code would be beneficial.
It's probably a good occasion to talk about SIMD.js.
Yeah, so SIMD, right.
Because ISM.js expresses effectively a compile intermediate representation in JavaScript. Mm-hmm. And to make that work, we need a capability in JavaScript to do all kinds of things that compiler wants to do. And one of those things is to execute vector instructions, which today is not possible in JavaScript. So one of the technology which Intel has been developing jointly with Mozilla and Google is called SIMD.js, mm-hmm. where again we are extending the language to introduce explicit vector operations so that either the programmer or Emscripten could say, execute these instructions on vector units, and that's exactly what would happen in native language to get performance.
So are there places where this would be a bad fit, or you would see actually a reduction in performance, and that sort of developers are, web developers, if they want to take advantage of some of these things, they'll have to like really know when to use the tool or when not to use the tool, or is it something they can kind of use with broader strokes?
I think that's always true of performance. You always want to measure before you jump in with both feet. And certainly with some of these technologies, the upfront cost is non-trivial. So when it comes to things like Parallel.js, like I described before with replacing a map with a parallel map, that's a very lightweight change, and you can sort of dip your toe in, see how it works, measure it, see if you got a performance increase. Something like ASM.js, and SIMD's sort of in the middle. SIMD's a lighter weight JavaScript API, but it's it takes a little bit of learning. And ASM.js really requires a whole different tool chain. You're buying into some technology there, and mm-hmm. so you'd want to know that it was a good fit for the kind of problem you're solving.
Mm-hmm. Does this sound like the kind of things that you guys could use at Famous?
Yeah, I think all this stuff is great news really for framework developers as well. And I'm sure you guys will take great steps to make this accessible to the average JavaScript developer. But things like what you're working on, the fact that WebKit, Gecko, Trident, those are actually converging and they're actually pretty similar across devices that matter right now. The fact that JavaScript's gotten super fast over this, since 2008. Mm. This is great news, not just for people who are working directly with your stuff, but I think the broader set of people who will be working with the frameworks that come out on the backs of your performance work, which is what my guys are doing.
So it's good for everyone.
Yeah.
So speaking of rendering engines, do you want to talk about Servo a little bit?
Sure. So this is still a relatively new project at Mozilla Research. Servo is a next generation browser engine. So we're really rethinking how the entire engine is designed, really around two key concepts. The main one is parallelism. So we've been talking about parallelism for the end developer. How can JavaScript developers use parallelism? But there's a lot of opportunities just inside that black box of the browser itself that could be parallelized better. On top of that, the other thing we wanted to think about was how can we build a browser on more secure foundations? So C++ is a very difficult programming language to make safe applications in, and security is a really important part of the web. So we actually have developed a new programming language that's sort of a competitor to C++ called Rust that is built around safety and parallelism as its kind of two key themes, mm-hmm. and Servo is being implemented in Rust.
And where would that run? So is that something that you would write that would sort of be familiar to a JavaScript developer, or something that you would include in the front end, or is it something that's compiled in the back end? Or?
It's the back end, right? So this is really the internals of what makes the browser go. So this is replacing, we use C++ at all of the browser vendors. Basically, all browsers are implemented in C++, all production browsers. And so we developed Rust as an alternative programming language for us to implement a browser out of.
So, I mean, there's a lot of different things that are all sort of driving toward better performance on the web, or for web developers and web-based applications. So what's the story? Like, what can a web developer do today to start to benefit from any of this, if anything, or is it just sort of sit tight, it's coming soon. You know, you'll be able to write super fast stuff. Stick with us for 6 more months, 12 more months, 18 more months. And before you know it, the browser is going to be so fast you won't be able to tell the difference between native and web.
I don't know. I think for developers who want to create these beautiful, engaging applications in web technology, one really interesting thing that might happen this year is the final domino might fall in terms of browser manufacturers making WebGL available to application developers. And Firefox did it, Google's doing it. The question is Safari going to do that? Is this going to completely change the game for what it means to build something with movement and magic in web technology?
That would be interesting because if we made a shift to a WebGL as like the way to create a really engaging, rich experience on the web, that would be a huge shift for the average web developer.
I think that would be a big shift for me, for the people who I'm trying to serve. Right now, the approach that I think we at Famous are taking, in addition to building what we think is a pretty exciting, performant JavaScript execution and rendering engine, in addition to a physics engine to control motion, is really just trying to set the bar for what applications can look like on using web technology.
Yeah. At Mozilla Research, what we're trying to do is sort of a combination between some of these really far out stuff where Servo may not hit the market for a couple of years, so that's really investment in the long term. But then technologies like ASM.js, one of the compelling parts of ASM.js is that because it's a subset of JavaScript, because it works today in any JavaScript engine, it means people can actually use it now, and it's building on optimization paths that were already happening in the existing browsers. So we were basically leveraging some existing competition and adding a little bit more impetus to it, and we're actually seeing browsers step up their game a little bit more and optimize even further. So what we were trying to do is build on an existing evolutionary path and just kind of provide some extra incentive for it to move even faster.
Parallel JavaScript is somewhere in the middle. It's getting there. Anybody who wants to get a feel of what it's going to look like can download Mozilla Nightly. And it's already there. Not all the capabilities, but enough to understand how it's going to be. Looking in the future, it's coming. We are making good progress. We're working with Mozilla on implementation. At Intel, we are working on Chromium implementation. So I would say by the end of the year, it should be there. And I think my message to web developers, especially for the framework developers, would be it's time to start thinking parallel. The hardware is there, the language is coming. Now we need application developers to look into their applications and say, what are the things in my applications which I know okay to do in parallel? So
there's actually something I wanted to bring up and I forgot, so let's potentially loop back to this. Some of the things that you guys are talking about with JavaScript advancements, we're talking about them in the context of the browser, but do they also apply to the server? So things like Node.js, parallelism there.
Absolutely. As soon as you've got a technology that's pure JavaScript, it's as soon as V8 implements it, Node can enable it and land it. And I certainly heard, like when we announced ASM.js, a lot of excitement in the Node community about using that.
Great.
There's just so much being written in JS now. It's the one language that's almost guaranteed to be there, going from the browser to the server and back. And on the server, you've had a lot of choices for a long time. There was Perl, and then PHP and Python and Ruby and all that. And those are all great in their own respects. But none of them subsumes the functionality of JavaScript on its own. Plus, you have, with advancements in the performance of these JavaScript engines that are now being applied to the server, this Cambrian explosion of JavaScript-based frameworks, and there's no reason not to use them on the server and the client if you can.
Exciting. A lot of exciting stuff for web developers in the relatively near future, if not now. So great.
It's fun times.
Very nice. All right, that's all the time we have today. Thanks to each of our guests, and thanks to you for joining us on Inside the Brackets. See you next time.